Record now. All right. So we're doing Pythagorean theorem 8.1. This is something you guys have already learned, but it's something that I want to like remind us about and like have an official lesson on. So like now we can officially know what's happening and be responsible for this. So just basics of Pythagorean theorem. It happens in a right triangle. You can only use this in a right triangle. In a right triangle, the sum of the square of each leg, the sum of the square of each leg equals the square of the hypotenuse. Now that's a lot of words to just say a simple equation that you guys all know. The sum of each square is a squared plus, sum means plus, b squared equals, and then the square of the hypotenuse is c squared. A squared plus b squared equals c squared. And if you forgot, I've got a little drawing next to you about a and b. It doesn't matter which sides you label a and b, those are just your legs. But the side that does matter is the hypotenuse. That's the side across from the right angle. We label it c. So if I say like what's c or what's the hypotenuse, I mean the longest side. I'll even write that next to it, longest. And that will come into play later. All right, easy stuff so far. Any questions as of yet? Okay, we've got a few problems where we're just solving Pythagorean theorem. So this first one says solve for x. I've got one side 9, one side x, and one side 12. Can someone tell me which side is my hypotenuse? Which side is your c?
X.
X.
Very good. The side across from the right angle is c. So that's the one that goes by itself. 9 and 12 just go together on one side of the equation. So I've got 9 squared plus 12 squared equals x squared. And again, doesn't matter which order you put them in, because now we're going to square them and add them together. 9 squared is 81. 12 squared is 144 equals x squared. 81 plus 144 is 225. And then I got to do square root of both pieces. Square root of 225, square root of x squared. That cancels that out. So I'm left with just x on one side. And then the square root of 225, oh, that's a perfect square. It's 15. So I can just leave it like this. If it is not a perfect square, hint, the next one will not be a perfect square. We're going to have to do a factor tree. But if it's perfect, and if you're not sure, you can always check it in the calculator. This one's perfect square, so I get to just write 15. Questions so far? All right, we got 2 more. Let's keep rolling. Next one says solve for x, express your answer as a simplified radical. So that means I don't want a decimal. It means I want an exact answer. It means that it's going to be a number and then radical another number. What's my c on this one?
9.
9. Very good. Thank you, Isaac. 9's your c on this one. So it doesn't matter how you write 7 and x as long as 9 is by itself. So I'm going to say 7 squared plus x squared equals 9 squared. 7 squared is 49. X squared equals 81. Let's minus our 49 from both sides. And I get x squared equals 32. Okay, square root both sides, get rid of that square with the x. Ooh, I already know 32 is not a perfect square, so I'm going to do a little factor tree off to the side. So 32. Factoring that down, okay, I know that 32 is 4 and 8, and 4 becomes 2 and 2, and 8 becomes 4 and 2, and then 4 becomes 2 and 2. Okay. I'm going to do this real slowly because I assume you were not doing factor trees over spring break, which is okay. Remember that you took 4 and 8 and you kept factoring those down. So those don't get to be included in anything. So sometimes you're like, well, I see 2 4s. Well, that's beside the point because we already took it down as far as possible. Now I look for pairs of numbers. So if I can see 2 numbers that go together, so like there are 2 2s, so I get to take 1 2 out. I see another pair of 2, so I get to take another 2 out. And then the last number that's like at the bottom of its branch is this 2, and he has no friends. No match, no friend, no pair, so he has to stay under the radical, so it becomes 2 times 2, root 2, and the 2 times 2 becomes 4. So the same thing, root 32 is the same thing as 4 root 2, and that's the best answer. That's the most exact, that's what I want. So half the battle is doing your Pythagorean theorem to get to radical 32. The other half of the battle, though, is to factor down root 32 to make it 4 root 2. All right, any questions so far? All right, we got one more example before we're going to add like another curveball in here. Speaking of curveballs, I hear it's softball and baseball's first game today, so good luck to those people. I've got some baseball players in here, right? Yeah? No? Yeah, okay.
Yes.
Isaac's nodding at me. Colin said yes. Okay, well, good luck today to you guys. I don't know if I have any softball players. Any softball players in here?
I play, but I can't this season.
Oh, Allie. Well, a softball player in spirit. So good luck to those teams. Good luck to you guys. We're thinking about you. All right, now off sport note, let's get back into math. So I have a problem here that actually looks like last section, last 7.4, 7.5 with my heartbeat theorem. I've got like my little altitude here. I'm gonna argue that we're not gonna solve it that way today though, because A, I don't know if this is a right angle, so I don't get to do heartbeat. And second is because it's in Pythagorean theorem, so I'm gonna use Pythagorean theorem to solve. So I'm gonna look at this triangle right here. I've got a little right angle. I know that the right angle on the left side means that it's linear pair is also a right angle. And this little orange triangle gives me sides of 6 and x, and then 10. I know 10 is c because it's across from the right angle. So Pythagorean theorem. 6 squared plus x squared equals 10 squared. 6 squared is 36. X squared equals 100. Minus 36 from both sides. I get x squared equals 64. And then square root x, 64 is a perfect square. So x equals 8. That was nice. Ooh, sorry. That's an easy one because it was a perfect square. Any questions so far? All right, let me erase some of this nonsense on the picture. I know that instead of writing x, I can write 8. I know that this little bit right here is 8. How much is this segment right here?
4.
4, very good, Colin. I had 12 as the whole minus my little part that's 8 I just found, so that leaves that this part is 4. So now I'm going to look at this triangle, the one not on the right, but on the left this time. I've got sides that are 4 and 6. This time my C is your Y because I don't know what my hypotenuse is, and so we're going to solve that. In my other class, some kids asked, well, could we do the whole triangle? Could I do like Y and 10 and 12? Again, I don't know if this angle is a right angle, so I cannot do that unless I knew for sure that was a right angle. So I'm just looking at the little triangles by themselves. So let's do this. I've got 4 squared plus 6 squared equals y squared. 4 squared, 6 squared, y squared. Okay. 4 squared is 16. 6 squared is 36. Y squared, we don't know. 16 plus 36, I think, is going to be 52. And then now I got a square root. Ooh, but I already know that root 52 is not a perfect square. So I'm going to have to do a little factor tree off to the side, root 52. 52. Okay, I know you can divide that by 2. 52 divided by 2 is 26. And I can do 26 divided by 2, and that's 13. Ooh, and that's as low as I can go. But that's okay because I do have a pair. That pair is 2, so I can take a 2 out. And then the 13 has no friends, so he stays under the radical. So root 52 is the same thing as 2 root 13. All right, so we had to do 2 Pythagorean theorems, one to find x, and then we had to use x to get the segment of the other triangle in order to find y. So all we've done is Pythagorean theorem. Again, something I think you've learned in middle school, but I just wanted to remind ourselves. So does anyone have any questions so far? No? Okay. The next thing is also something I remember teaching you, but I also know it's been a while. So the next part says, recall from a previous chapter. This might have been when we were online because I have kind of faint memories of trying to like show you this through the Zoom screen, and it would have been easier to do it in person. So I understand sometimes stuff that we learn on Zoom we don't like recall as nicely, but this says to determine whether a triangle can be formed from 3 segment lengths, we use triangle inequality theorem, which states that the two short sides of the triangle, or the 2 short lengths, must be greater than the longest side. So essentially, if I give you 3 numbers, we want to take the 2 smaller numbers and see if they sum or together they add to be more than the longest side. Essentially, we're doing A plus B and seeing if that's bigger than C. And if that's true, then we have a triangle. If that is not true, then we don't have a triangle. So again, I don't know if you remember learning that, but I remember taking like little segments on my desk at home and trying to like put them together to show you like, yes, they make a triangle, or like no, if it was too small. I don't think I have a small enough thing, and I use like this cap, I guess. Like these 2, I don't know if you can see my face, but these 2 small segments will never make a triangle because there's no way they'll ever touch each other. But if I use long enough ones, they can go end to end because the 2 small segments are bigger than the third one. Again, it would be easier if I could show you in person, not in person. That's the best I can do via video. But what we need to do with these next 2 problems is figure out which is the biggest side and see if the 2 smaller ones are bigger than that. We need to use this this theorem in the next section, but we're going to practice it with just deciding whether it's a triangle. So the first segments I'm giving you are 5, 11, and 6. So we want to pick the 2 smallest ones. 5 and 6 are the smallest numbers between 5, 6, and 11. So I'm going to say, okay, does 5 plus 6, is that bigger than 11? 5 plus 6 is 11. Is 11 bigger than 11? No, right? So that's silly. It's not greater than or equal to, it's greater than. 11 is not bigger than itself. So we're going to write not a triangle. It's not a triangle. It doesn't exist. There's no way that will work. Anybody questions so far? Same idea for the next one. Again, pick the 2 smallest lengths. So between 13, 5, and 7, 5 and 7 are the smallest lengths. So I'm going to do 5 plus 7 and see if that's greater than 13. Well, 5 plus 7 is 12. 12 is definitely not bigger than 13. 12 is decidedly smaller than 13. So again, we're going to say not a triangle. So if they're equal to each other, it's not a triangle. If the 2 smaller sides are smaller than the third side, it's also not a triangle. Now, if it is a triangle, then we're going to continue on to do another step that we're going to learn on the next page. All we've learned on the first page, though, is Pythagorean theorem, and then to remember how to see if 3 segments make a triangle. Anybody have any questions so far? Okay. Go ahead and flip your paper over or scroll up or whatever you're doing. I don't know how you're taking your notes, but we're going to the next page. And this is the last like new concept, and then we're going to put all 3 of them together. This is called the converse of the Pythagorean theorem. So I keep referring back to chapters 2 and 3. Those were super important chapters. And chapter 2 was using converse, conditional, contrapositive, all those fun things. So again, if you can see my face, I've got little thumbs up. If you remember back from chapter 2, we had conditional statements where like, if something is true, then this thing happens. So like, if you're in geometry, then we're in class right now. I don't know, that was a stupid one, but if-then statements. Converse means that we switch them. So we'd start with the then, and then we'd end with whatever the if was. So Pythagorean theorem, if you recall, I'm going to scroll up. It's in a right triangle. So if it's a right triangle, then a squared plus b squared equals c squared. That is the statement. If it's a right triangle, then this statement is true. A squared plus b squared equals c squared. When we do the converse, it means that we're going to say if a squared plus b squared equals c squared, then it's a right triangle. So this whole time, if I'm doing converse of the Pythagorean theorem, we are proving whether it's a right triangle or not. So if you do Pythagorean theorem and it's not true, the two sides squared don't equal the third side squared, then it is not a right triangle. So we're going to write it in words, and then we're going to write it kind of in shorthand note in that box below. So it says, if the square of the length of the hypotenuse of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. In SparkNotes version, that means if c squared equals a squared plus b squared, then we have a right triangle. Whoa, sorry. So again, this is, we don't know it's a right triangle. We're proving that it is. We're going to say, okay, if c squared equals a squared plus b squared, then we have a right triangle. Okay, everyone okay with that part? Now, we could solve a squared plus b squared, and it could not equal c squared. It might be bigger than or smaller than or just not equal to c squared. That means it's not a right triangle. And then that means it has to be one of the other types of triangles. So we've got right triangles where you've got a right angle in the corner. You've got acute triangles where all the angles are smaller than 90. And then we've got an obtuse triangle where one angle, whoa, that's not a triangle. One angle is bigger than 90. So those are the three types of triangles we have, right? Acute or obtuse. We knew that, just reviewing. If c squared is less than a squared plus b squared, then that triangle is going to be an acute triangle. I think of acute and less than because all the angles are less than 90. So I think less than, small, acute, I think those kind of words go together. I associate them together in my brain. If c squared is greater than a squared plus b squared, then that triangle is obtuse. Obtuse, bigger, greater than, bigger than 90. Those words go together in my brain too. So less than acute, greater than obtuse. I also highly encourage you to write it like this: c squared equals a squared plus b squared. Put the c squared first, because then the less than and the greater thans will match up like you want them to. If you do a squared plus b squared first, it gets a little confusing. So I'll try and model that on my paper in a second. So what we're doing for the rest of the problems on this page is we're going to do c squared equals a squared plus b squared. And we're going to decide whether it's a right triangle, an acute triangle, or an obtuse triangle. Anybody have any questions so far? Okay. The first example says, tell whether the triangle is a right triangle, show calculations. Okay, so I already told you that we're going to do c squared equals a squared plus b squared. And on the other page, every question I asked first was, what's my c? And you guys were like, easy, it's the one across from the right angle. Well, there's no right angle here. One thought you might have is, oh, well, this looks like it would be the right angle, so this looks like it would be the bigger side. Okay, that's legit, not like factual, or it's not like based in fact, but it's not a wrong guess. Another guess you might have is, oh, well, I think 12 is the bigger number because 6 times something would have to be bigger than 12. So I think 12 might be the bigger number. Again, legit reasoning, not necessarily based on fact. The fact I want you to use is I want to figure out what this is in terms of a decimal, because then I can for sure say it's bigger or smaller than the other numbers. So let's do that in the calculator. So I'm just pulling up a calculator next to us, and I'm going to write 6 radical 5. And you can do this in your little handheld ones that you guys use on quizzes all the time. 6 root 5. that equals 13.4, blah, blah, blah. So I'm going to go over here and write approximately 13.4, blah, blah, blah. That's all I need the calculator for, so we'll get rid of it by calculator. So once I rewrote that as 13.4, now I can think, okay, 6, 12, and 13.4. 13.4 is for sure the biggest one. So this side is my C. The other two are my A and B. It doesn't matter which one goes where. It just matters that they're not C. Anyone have questions on my logic to decide 6 root 5 is the biggest number? I know that was like long-winded, but I tried to like think through different like thoughts you might have before I told you exactly what to do. So again, I put it in the calculator. I saw it was the biggest one. So now I'm going to set it up over here. C squared is my 6 root 5 squared. A squared is 6 squared, and then B squared is 12 squared. Again, you could easily, you just did 13.4 in the calculator. You could just square that. I trust you can use your calculator. What I don't know that all of us can do is do 6 root 5 squared on paper by hand. So I'm going to explain that one out. You'll get the same thing whether you put in the calculator or whether you don't. I'm going to explain it by hand though. So if I do 6 squared on the other side, I've got 36 and 12 squared is 144. Okay, the right side was really easy. When you do the left side, I have to square 6 and root 5. So 6 squared is going to be 36, and then radical 5 squared is radical 25. Well, radical 25, you know that's a perfect square, so that's just 5. So I essentially have 36 times 5. You could have, if you feel strong enough in your math, you might have just known, okay, the square root and the square cancel each other out, and you could have gone directly to this step and just known it was 5. That's fine. Sometimes we don't connect the dots yet, so I just wanted to like go step by step through this. Anybody have any questions so far? Okay, now I'm going to multiply 36 times 5, and I get 180. And I'm going to add 36 plus 144. Oh, and I also get 180. How fun is that? They equal each other, which is good, which means C squared equals A squared plus B squared. That is a true statement. So that means that we have a right triangle. So there was no variable to solve for here. We just were seeing, is this true? Do both sides equal each other? If so, then it's a right triangle. If not, and we're about to do a couple examples of it not working, then it would be an obtuse or an acute triangle. Okay, anybody have any questions so far? Okay, on the next set of instructions, we cannot go directly to C squared equals A squared plus B squared. We first have to decide whether it's a triangle. So I have to add my 2 small sides and see if it's bigger than my third side. Once I say yes to that, then like the gate is open and I can actually do the real problem. And the real problem is deciding whether it's right, acute, or obtuse. I'm going to do letter A all together with us, and then I'm going to be quiet for a few minutes and let you try B, C, and D, and then I'll do those before we're all done for today. So if you feel good, I want you to start this on your own. You can just kind of half listen to me, but if you're really not sure where you're going, stay with me because I'm here with you. So first says decide whether it can represent a triangle. Okay, so I have to do the 2 small ones. 6 plus 9, those are my 2 smallest sides. I have to see if that's bigger than 10. 6 plus 9 is 15. Okay, 15 is bigger than 10, I believe that. I'm gonna say yes, it's a triangle. So I opened the gate, I did the first step, and now I get to like actually solve the problem. If this is a no, you're done. There's no way for us to decide whether it's a right, obtuse, or acute triangle because it's not a triangle. But it's yes, so I have to solve it. I have to put my C by itself, so I'm going to do 10 squared equals 6 squared plus 9 squared. Again, I highly suggest setting it up this way because it matches our like little formula thing above. 10 squared is 100, 6 squared is 36, 9 squared is 81. 36 plus 81 is 117. Ooh, this is not as nice as the last one. They do not equal each other. Okay, But just because they don't equal each other just means it's not a right triangle. Now I have to ask myself, is it acute or is it obtuse? Before I go up and look at my notes, I'm going to decide what my inequality sign is here. It goes 100 and then it goes 117. I'm going to do a less than or greater than. In this case, I'm not great with less than or greater than. I know it's like second grade math, but I know I struggle with it. So if you struggle with it too, it's okay. I know 117 is bigger, so I have to have the opening go to the bigger one. So it's a less than. 100 is less than 117. Okay, cool. I'm going to go up now and see what it means when c squared is less than a squared plus b squared. Zoom, zoom, zoom. If c squared is less than a squared plus b squared, then it is acute. Okay, cool. So c squared is less than a squared plus b squared. So this is an acute triangle. Again, I had to solve whether it was a triangle first, and then I did a squared plus b squared, and I saw that since it was less than, it was acute. Anybody have any questions? Okay, I'm going to do the other three, but I'm going to stop talking for a second. I want you to try letter B on your own now. If you get done with letter B, go to letter C. If you get done with letter C, blah, 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 go to letter D. Take a second, see if you can set it up, and I'll leave my work up, and then I'm going to go over these three together, okay? Go ahead, try it on your own. Okay, take another minute. Okay, let's look at letter B together. If you're still working, you feel good, keep going through the rest of them. If you are not sure what's happening, come talk to me on letter B. So I've got my three segments. I've got 8, 18, and 24. First thing you have to do is check to see, can this be a triangle? So I have to do 8 plus 18. Those are the two smallest sides. Is that bigger than 24? 8 plus 18 is 26. Okay, yeah, I agree. That's bigger than 24. So we're gonna say, yes, it's a triangle. Now we open the gate, we get to decide what kind of triangle it is. Again, I want my C to be by itself. So I'm gonna do 24 squared equals 8 squared plus 18 squared. 24 squared is 576. 8 squared is 64 and 18 squared is 324. So those are just plug and chugs on the calculator, so I'm not going to spend a lot of time going over those. I am going to add 64 and 324 together though, so 576 is equal to 388. Ooh, that's not true. Those two numbers are not equal to each other. So let's write our inequality. So it's not a right triangle. I already know that. I have to decide now if it's acute or obtuse. So it looks like the bigger number is 576. So I'm going to write a greater than sign. So C squared is greater than A squared plus B squared. Okay, let's go up and see what kind of triangle that is. I'm referencing my notes and it says if C squared is greater than A squared plus B squared, then it's obtuse. Great. All right, I'm going to write obtuse triangle. All right, that wasn't too bad. So I know I'm all over the place. Anybody questions on letter B? All right, let's do letter C. All right, first I got to decide if this is a triangle. So I'm going to do my two small sides. 2 plus 2, is that greater than 5? 2 plus 2 is 4. Ooh, 4 is not greater than 5. That is not true. Okay, well, I didn't even pass the test, even open the gate. This is just not a triangle. So because it's not a triangle, I don't have to do the other step. I can't decide what kind of triangle it is because it's not a triangle. So I tried it. It doesn't work. I just write not a triangle and then I move on. So I've got one less step. I don't have to do any of this work over here because it's not a triangle. Okay, so we've done an example of an acute triangle, an obtuse, and then not a triangle. We did an example of a right one above. So now we've done an example of everything. We're just going to see what this last one is. Anybody have any questions so far? Okay. The last one says 6, 7, and root 13. Ooh, this is kind of like the last one where we have this weird radical. Let's decide what that is because I don't know what my smallest, biggest, medium number is here. So I want to make sure I'm adding the two smallest ones to see if it's bigger than the third one. So I'm going to get my calculator back out and I'm going to do root 13. Square root of 13. And I get 3.6, blah, 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 blah. So instead of root 13, I'm going to think of this as 3.6. All right, cool. Okay, that helps a lot because that tells me 6 and this 3.6 are my two smallest sides. So I need to do 6 plus 3.6 and see if that is greater than 7. That becomes 9.6. Oh, for sure, that's definitely bigger than 7. Okay, so we open the gate. We can actually solve this problem. I don't need my calculator anymore. Bye, calculator. That means that 7 is my biggest number. So I need to have 7 by itself over here. 7 squared equals 6 squared plus root 13 squared. I like to do root 13. Again, you can put in the calculator. I trust you. I believe in you. But I also want you to have the skills and see it if it's, whoa, I didn't mean to do that. If it's by hand. So if I square 7, I get 49. If I square 6, I get 36. And if I do the square of the square root of 13, then those two numbers, the square and the square root, cancel each other out. And I'm just left with 13. You can also think of that as like root, what is it, 169, and then that becomes just 13. You can do that extra step if you want. It does not matter to me. So now I have to do 36 plus 13, and that's 49. Oh, and 49 equals 49. Yes, that's exactly what we want. Perfect. That makes it a right triangle. That's what we want. Yay. That worked out so nicely. All right, so if you look at these last 4 we did, and I guarantee there are ones like this on the homework that I'm about to point out, we had to do had to decide whether it was a triangle, and then we had to decide what kind of triangle it was. So you essentially need like 2 pieces of work for each of these problems. I'm going to again preview the homework again. Does anyone have any questions on what we're looking at right this minute? Any questions on the notes at all? Okay, let me jump over to the homework really quick. I do not see you tomorrow, but I see you on Wednesday. So tomorrow's a day 4. I don't see you guys on day 4, but I see you on Wednesday, which is a day 5. So this homework is due on Wednesday. I've got some basic Pythagorean theorem at the top. 7 through 12 is just like the 4 problems we just did. You have to show me, is it a triangle on like the top part where this triangle question mark is? You have to do the 2 pieces. So like 3 plus 8, see if that's greater than 10. And then if it is, then we have to do c squared equals a squared plus b squared underneath it. So like if you just write like right or cute, just willy-nilly, like we're gonna have an issue, but you need to show me those work. This is like the last 4 we just did. The back page looks a little bit different, but I want you to break it down into triangles. So these word problems above look harder than they are. They're just triangle problems. So try them out. We'll go over them tomorrow, or sorry, Wednesday. And then the last ones are simplifying radicals. So it's just practicing your factor trees and all that kind of stuff, and multiplying all those things out. Anybody have any questions so far? Okay. I'm going to dismiss you from class. I'm going to be on Zoom for the rest of class time. So if you need anything, come talk to me. If you're all good, then have a good rest of your day. See you guys on Wednesday.